Today we're talking a little bit about our charger here in the garage. It is actually a Clipper Creek. I have talked about it before, but it is actually attached to an extension cord, a NEMA 1450 extension cord. And the other day it actually did have a problem with the actual connection. And we'll talk about it today. So I'll put a picture up on here, but it did the other day. The connections between this and that did actually have a problem. The old parts are actually here. So we do have, this was from the actual Clipper Creek itself, and this was from the extension cable. As you can see, it did actually get very hot and it melted. So I'm not sure if some moisture got in there or something that caused it to actually have this problem, but it did actually cause it to have a fault. So the Clipper Creek here has, whether it has power charging, power fault, and charging fault, it would have a power fault with a red light on it when this occurred. And so what we had to do is actually purchase a new set of these so that I could actually take these two wires apart. So I took the extension cord, basically cut off that piece, cut off the piece on the actual Clipper Creek, and then put these new actual connectors on there. What was interesting about the Clipper Creek is that it actually was set up with a 3-wire setup when there should be 4 wires, as would normally be the case with the 4 prongs there on the plug. Supposed to have the ground, the neutral, and one for each of the 120 powers. So you have a 120 and then a 240. So the thing is that actually it was set up sort of like a NEMA, I'm not sure, but it's 3 wires. So it only had 3 wires in it. And so I had to figure out how to actually connect the 3 wires. And what it turned out was, basically, if you don't need the 120, then you can just set it up with just the 240. And that is the case for our EVSE. We only care about it getting the 240 volt instead of just doing the 120. 120 would be like on an oven. You might need, like for the clock, you need the 120, and that's why it has the NEMA 1450. So it has the 120 actual power along with the 240 for the heating element. So in the EVSE, all it needs is actually just the 240. So we were able to basically rewire it just so that it had the 240, and that was able to get it to work just like it did before. And obviously that's how it was previously, because even though it did have the NEMA 1450, it did only have 3 wires in it. And our cable for the extension did have the 4 wires, but you didn't need one of them to connect for the 240 volt. So anyway, that was just a quick overview of our situation there, where it did overheat. I'm not really sure why it overheated or what exactly caused maybe the moisture to get in there and ended up melting those 2 connectors together. But definitely be on the lookout for that. Any type of electrical situation where it's going to be overheating like that, you definitely don't want that to be happening, especially when you're out and do not have any ability to take control of the situation, get out of the house, whatever the case may be. So I have been actually keeping an eye on it since then, just to make sure that there has not been any other overheating situations. There hasn't been, so I'm not really sure exactly what caused it. I still would prefer that we get a hardwired Tesla connector, but it's just really not in the budget at the moment. But whenever it is, I definitely want to get a hardwired Tesla EVSE so that way I know that it is all set up the way it should be, instead of using this extension cable that, yes, it is a nice like 6 gauge. So it's like a nice heavy duty wire. So it definitely can take that amount of amps and everything continuously, and it should be fine, because that's something that you would use for like an RV, hook it up for like long periods of time. You hook it up a campsite or whatever. This is just hooking up our EVSE for long term. So it should work, it shouldn't be a problem, but obviously it would be better if it's just hardwired all the time. And the only reason we had to do this is because we actually wanted this charger to be within reach of all of our cars. So we have 3 cars. We got 2 that are in the garage that we can charge with it, and then 1 that has to charge outside the garage. And in order to reach that one outside of the garage, we obviously had it closer to the end of the garage, which when we originally installed the EVSE, it actually charged the cars in the front of the cars. So we had like a Leaf and a Pacifica hybrid, which has a plug-in on the front. So those plugins actually worked for the front of the vehicle, but now we need to get the Teslas charged. So before, we had to actually back one of the Teslas in and have one of them in nosed in, and they would both be able to charge no problem on that. But then once we got the third car, basically we just had to change the location. And now that we have the changed location of that charger, we can actually charge all 3 cars with them all just going forward into the garage or in front of the garage. So anyway, just something to keep an eye on. If you have a charger in the garage, or if you're thinking about installing a charger, I would definitely try to install it hardwired if at all possible. Even get a hardwired one versus the one that has the plug on it. It is nice to have the plug, because we did actually take that charger from a previous house and we were able to move it here by just installing a new outlet. However, that convenience does have a side risk or possibility of it not being quite as durable or able to take the elements and that sort of thing. So anyway, thanks so much for watching, and we'll catch you on the next one.